Hey guys, welcome back. What's up? Sorry about the tardiness of this video. I thought I had one ready to go, and apparently I did not. And so I'm not sure what happened to it, but anyway, we're gonna have to remake it. So here we go. This week, we're gonna begin chapter 2, and we're starting out by looking at first, how do we describe position in a data set? Sometimes we want to talk about where does that data point fall. We've seen some examples of it already, like we could say, oh, it's Q1 or median or Q3. And that tells you kind of where it is in terms of the quartiles. But maybe we have some other data points we'd like to describe their position. We'll start off with percentiles. I think you guys have probably seen some percentile rankings before. When you do a standardized test, a lot of times you get your percentile rank. And so when we talk about the percentile rank, basically we're saying, what percentage of the data points are less than your number. So, what percentage of the data is below a particular score. And so, when you say you're in the 50th percentile, right, then that means you did better than 50% of the folks. 80th percentile, you did better than 80% of the folks. So, when you got your percentile ranking, whether it was a map test or you haven't done the SBA exam for high school yet because we didn't do it last year. Maybe you did one a couple years ago, but you've seen some percentile ranking stuff that's come your way. So I guess for you guys, you probably won't be taking any SAT tests because, a lot of schools aren't requiring that this year. Thank you, COVID, which I guess is one of the perks of having the COVID stuff happen. So percentile ranking, that's really all it is. So just figure out, how many scores are below you out of the total number of scores that are available. The highest percentile rank is always the 99th percentile. Because you are part of the data set. So, if there's 100 data points and you got the best score, you're better than 99% of the data. So, so percentile rank's a nice way to describe position in a data set. The median represents the 50th percentile, right? The Q3 is the 75th percentile. So there's some nice things in there in terms of figuring out percentile rank for the quartiles, but you can do that for any data point. Just take a look and see how many data points are less than that. That sort of brings us to an idea, though, that and a particular graph that we need to talk about here. It deals with something called cumulative frequency. And so I'm going to leave percentile rank for a minute and talk about cumulative frequency. There we go. And what that means. And so to describe this, what I'm going to do is I'm going to make just a little table here. If you have your book, I'm taking the data straight off of the frequency chart here that's on page 86. This is the age of the first 44 US presidents is what they have there. And so let me show you what their table looks like, and then we'll add a data point for our current president. Because we actually have had 45 presidents. So they have age groups here, and then we have frequency here. And then I'm going to add something called cumulative frequency. So, we have their age, and we have the frequency that goes in this column. And then we're going to come up with something called cumulative frequency for this last column. And if I'm looking in here, they've given me the following age bands here. So 40 to 44, 45 to 49, 50 to 54, 55 to 59, 60 to 64. Looks like I'm gonna need more. And 65 to 69. We're going to need another one for Donald Trump. Oops, because he was older than 69 when he was first inaugurated. So there we go. Now I obviously need to extend some of these down here. There we go. And oops, there we go. So when I fill out my frequency table, then all I'm doing is just putting in how many presidents are in each of these categories. There have been 2 in that category. There's 7 that goes here, 13, and then 12, and then 7, and then 3, and then 1 more for Donald Trump. So there should be a grand total of 45. The data in the book has the data from the first 44 presidents, but that's because our book was printed before we had another president. So yeah, it was only current up through the Obama presidency. So now cumulative frequency then is basically kind of like doing percentile ranks. It's like how many people are, or presidents in this case, data points, are below the upper bound for whatever class we are working in. So for the first category, that's easy. Cumulative frequency is exactly equal to its frequency. There's 2. But then when I get to the next class, I'm asking for cumulative frequency, how many presidents are 49 or younger? Okay, well then that means this cumulative frequency would be 9. And when I get to the third class, I'm asking how many presidents have been younger than 54 years old? Okay, so you take your 13 and you add that on here. So we get 22. How many have been less than 59? Well, we add on 12 more, so we get 34. Less than 64, 41. And less than 69 years old, there were 44. And now with Donald Trump being president, he was inaugurated, he was 71 years old, I think, or 70. So 45. So there you go. That's cumulative frequency. So it's just a matter of adding up all the data points below it. Okay. The graph that shows cumulative frequency has a special name. Okay, so let me forward to one page here. So what I'm going to make is called a cumulative frequency graph, or it goes by another name. And of course, College Board likes us to call it by its regular name. An ogive. I know it looks like it says ogive, but it's ogive. That's how you say that. That's the name of the cumulative frequency graph. So what I'm going to do here is I'm going to number this off. 5, 10, 15, 20, 25, 30, 35, 40. I've got to move a I've got a tool bar here. I got to get it out of the way, and we'll go all the way up to 45. There we go. Obviously, our axis needs to get a little taller. There we go. And then we go across and we mark off our ages. Now, I'm not going to start at 0, so I'm going to put one of those little breaky things in there. And I'm going to start with my first, go 40, 45, 50, 55, 60, 65, 70, 75. And I'm going to put down a dot for each cumulative frequency now. So, and I start at the left edge of the first class, and there have been 0 presidents that are younger than 40. Even though the Constitution says, hey, you could be 35 and still be president. We've never elected a president younger than 40. There are 2 presidents, though, who have been elected who are younger than 45. So I'm going to put a dot here at 2. Okay. If you can name them, do you know who they are? All right. And then we're going to go to our next cumulative frequency for 50, which is 9. So just a little bit below the 10 line. And then for 55, we're going to jump up to 22. And then we're going to jump up to 34 for 60. And then for 65, we're going to go to 41. For 70, we're going to go to 44. And I got to move that darn tablet toolbar again. And then obviously 75 just goes up one more. Oops, draw. Gotta get the pen back. There we go. And so an ogive, then you connect the dots with straight lines. And that is how you make a cumulative frequency graph for any data set. That's just what ours looks like. And then of course we would have a well-labeled graph. You know, this is the age at inauguration. Okay, this is our cumulative frequency. Oops, frequency there. And you could call it the ogive, or you could say it's a cumulative frequency of age of presidents. Like that. Ogives are not particularly commonly asked for, but for whatever reason, the College Board does seem to like this particular graph when asking questions on their AP exam. So that's a real quick and easy way to do the ogive. Now, the interesting thing about this is when you start making your ogive, if you change this cumulative frequency into relative cumulative frequency, then the axis over here becomes percentages. And then you can use it to find percentile ranks, which is kind of handy. You know, if I'm going to redo my graph here, I want to turn the vertical axis into percentages so that it becomes relative cumulative frequency. Okay, then we get a little bit different look to our graph here, but in terms of the labels, but everything else stays pretty much the same. So I'm going to label it. This is about the 20% line here. This is about 40. This is 60, 80, and 100 at the top. And so one of the things you can do, those aren't quite right, are they? Let me adjust this one down a little bit. See if I can get rid of these little guys. There we go. Oh, didn't mean to do that. There we go. 20, 40, here's 60, here's 80. These are pretty rough, guys. I'm trying to do this as quickly as possible for you. So then what we could say is, you know, using our cumulative, this is cumulative relative frequency. So these are now percentages. You can say, okay, well, where's the median? Like, what would the median age for a president be in this case? We'll just go to where the 50% line would be and go, oh, okay, it looks like the median age then would be, would be about 55 years old. You could say, oh, well, where's the third quartile? Well, let's go up to 75%. Say, oh, okay, that moves it over to about here. So that's about 60-ish, maybe 59. My lines aren't exactly straight, but yeah, so that's a cumulative relative frequency ogive can help you with percentile rankings. Obviously, Donald Trump, okay, is the oldest US president that we've inaugurated for his first term. And so because Ronald Reagan was older when he was inaugurated for his second term. But if Trump gets reelected, then he'll be older than Ronald Reagan. So they're going to battle back and forth. Oh, by the way, if Hillary Clinton won, we'd have the same thing. She would have been older than any other previous president anyway. So they are in the 99th percentile though. So because they're the 45th out of 45, so there's 44 that are below them. So so they would be older than most. Did you figure out the youngest two yet? Okay, JFK. Yeah, you guys got that one. Did you find out who the other one was? I'm not going to tell you. You got to go look it up. All right. So that's Ogive's percentile ranks, cumulative frequency. There's one more really, really important idea in this section. And this is an idea we are definitely going to use a whole lot. So it's why I wanted to make sure we got a video made for today. And I don't know what happened to it, guys. So you'd think being so important, I would have double checked the video quality, but it did not happen this weekend. The Z-score. All right, the Z-score. This is measures the location, I guess is a good way, of a data point in terms of standard deviations. In other words, the Z-score tells you where your data point is located relative to the mean in terms of number of standard deviations. Okay, so here's how you compute it. And this is a formula you will definitely need as we go through. So it is very important. The Z-score. Now remember, it's going to take your data value and tell you how far it is from the mean. In terms of the number of standard deviations. We are going to use this for the rest of the year. So very important that you understand how this formula works. Now, I haven't mentioned this until just now, but whenever you take a test in this class, you can always use whatever formulas you want. When you take the AP exam, they give you a whole packet full of formulas. If you've taken the AP exam in some other math, like calc, they didn't give you anything, right? We get a whole packet of formulas and tables, and we get all kinds of stuff that we can use. This is one of the formulas they give you. Hopefully, by the time you take the exam, though, this is not a formula you need because you will have it memorized. We use this one a lot. Okay, because what it does is it takes away all of the like how big the mean is of the standard deviation and just says, hey, if you wanted to look and see how far away from the mean you are, okay, you just take you just find your Z-score. So the example that I'm looking at here is on page 91 in your book, and basically Jenny gets a score on a chem test. And she got a score of 86 on her chem test, and she finds out that the mean for her class was a 76 with a standard deviation of 4. And so, you know, she's bummed because she got an 86, but she, relative to her classmates, how did she do? And so we could find her Z-score is 2.5. So she did 2.5 standard deviations above the mean. So actually she did pretty well. Okay, and this is really handy data for when you have like your obnoxious friend who's in a different chem section. So her friend, let's call it John, who's in another chem section, says, oh, well, I did better than you. I got a 90. Okay, and okay, yeah, raw points. He did do better than she did. But in his class, the mean was an 80 with a standard deviation of 5. So did he really do better? Well, when you look at his z-score, clearly the answer is no. You know, he did 90 minus 80 divided by 5. He did well. He's 2 standard deviations above the mean, but not as well when compared to the peer group that she's with. And lest you think I'm kidding about this, this is exactly how the University of Washington professors grade, at least as far as I can tell, especially in the College of Engineering. So I've had 2 sons now who are gone through the College of Engineering there at University of Washington, aerospace engineers. And when they're in their calc classes or their physics classes, or whatever, when they go to give grades, it's all about how many standard deviations above the mean are you. So my son Patrick, who's a junior right now, he will get a score back on an exam, especially like in physics, and he will get like an 86 out of 100 or something. Okay, but then when you look at the class average and you look at the standard deviation, turns out, if he's 2 to 3 standard deviations above the mean, then that's a 4.0 on the test. So, and that's how they grade. So, a lot of this stuff does happen relative to the mean and using this z-score. So, massively important idea, guys, that when we go through our year here, we are going to see z-scores quite a bit. So, that's pretty much it for today. There's a little bit in here about transforming data. We'll talk about that in class when we get to those problems, but I don't think that'll be too much of a surprise for anybody. And we'll take care of the rest of that when we get together. All right, thank you guys so much for tuning in. I will see you guys in class. I know, I'm sorry, second period, we're probably watching this video as part of class today. So, all right, thanks so much, guys. See ya.